Okay, this is the FRQ that we worked on in class on January 17th, 2024. There was a 2-hour delay. So I started the day in third period working on this, but those of you in second period are probably going to see this tomorrow, and I'll make this video available to you as well. We've got a table of values for a function f and its derivative, but only at 3 values for x. The question says the table above gives values for the differentiable function. That means that its derivative exists everywhere and the function is continuous, and its derivative f prime. And then this function h of x I've already got in my calculator. So the point of this video is not necessarily the calculus, because I think this is one of the easier FRQs that you're going to see, but I wanted to show you some of the calculator stuff. So the calculator is going to come back into frame time to time, and that's the main thing that I want you to get out of this video, even if you can't see the writing the best. So it says using values of f from the table, estimate f prime of 0. So this is a huge hint. They didn't have to tell you if you weren't sure how to get started. You don't want to be looking at f prime here. You want to use the values for f. Remember, f prime of 0 is a tangent line slope. When we estimate a tangent line slope, we use the slope of the secant line, which is a difference quotient. So f prime of 0 is approximately, so this is part A, is approximately f of 1 minus f of negative 1 over 1 minus negative 1. And the point here is that these values for x are on either side of 0. And so we find the slope of the secant line between these 2 points. We're approximating the slope of the function between there. And all of this is given. So this is 4 minus negative 1 over 1 minus negative 1, which is 5/2. Okay. On to part B. A is a function, f plus h. We want to find a prime at this value. And this is just a question about, do you know how to take the derivative of a sum? So if a is f plus h, then a prime of x. And I think this right here is what you would want to write to show work. It says show the work that leads to your answer in part A, but you're always showing a little bit, even if you're using a calculator. A prime of x is just f prime of x plus h prime of x. The derivative of a sum is the sum of the derivatives, and that's what we have here. At a prime of, what did I say, negative 1 is f prime of negative 1 plus h prime of negative 1. So we're just plugging in these values. So do we know f prime at negative 1? We sure do. That's 8. H prime of negative 1, that's the derivative of this function evaluated at negative 1. Now, this is a function that everybody should be able to take the derivative of. It's a product, so you would use the product rule. However, I want to show you on your calculator. I have x times the cosine of 5x squared. I'm going to use second trace. And instead of some of these other functions that we've used up here before, I'm going to use this dy dx function. This is a derivative. It's not going to tell me what the derivative function is, but it is going to evaluate the derivative of the function that I have programmed into y1 at a value. So this is telling me a slope. It doesn't actually tell me the derivative f prime. It just tells me the slope of the tangent line. So I hit 6. And there's the graph of this function. It's shown up here. Y1 is what I inputted here. It's not prompting me for anything, which is a little weird. But if I just type, and let me move the calculator up here, negative, not minus, but negative 1, you can see it accepted x equals negative 1, and then I hit enter. And it says dy dx is 9.873. And so this is 17.873. All right. For C, if you struggled on part B, hopefully by the time you figure out that the sum of the derivative is the derivative of the sums, or I guess I said it backwards. Here you can see that B is a product and C is a quotient. So this is going to be taking a derivative just using the product rule, and this is going to be a derivative taking using the quotient rule. We're going to need some of these values from the table, and we're going to have to compute some other values in our calculator. So B prime of x equals, all right, so this is a product rule. So first times the derivative of the second, which is h prime of x, plus the derivative of the first times the second, which is h of x. And then I'm going to plug in, this is being evaluated at 1. So x equals 1, 1, 1, 1, 1. Probably should write that again. I'm just trying to make this video pretty quickly. So do I know f of 1? It is 4. What is the derivative at, so I'm hitting 6 again. This time I want x equals 1. Enter. It's that same value. 4 times 9.873 plus, now the second part is, what is f prime of 1? That's 3. And now I need the value of the function h at 1. So this time, I'm not using dy dx, I just want to know the value of the function, and that's at 1. And this is 0.284. This is multiplication 0.284. Remember, we're using 3 decimal places. So this is about, so let's see, now we need to go 4 times 9.873 plus 3 times 0.284. Should be about 40.344. Alright, so that's part C. And now part D is the quotient rule. So notice that f is the one in the bottom. So this is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom over the denominator squared. And so we need, this is all at 3. So this is f of 3 is 6 times, we need to use our calculator to find this one, minus, we also need to use our calculator to find this one, and then f prime of 3 is negative 2 all over f of 3 squared, which is 36. So now we need, now what I found out from one of your classmates is that if you use the dy dx function and you put in x equals 3, now mine is has lots of fancy words like plus and silver, but it's actually not the most recent addition of this calculator, and so yours may have some extra features. So if you evaluate the derivative at 3, negative 76, let's see, that goes here, negative 76.045. Some of you have a calculator that will also tell you the y value of the function. It will have another line down here. It will say x equals 3, y equals something. I don't have that feature, so I have to do a separate step where I go back and I hit the value at 3, and 1.57 goes here. 1.576. All right, we're almost done. So this is 6 times negative 76.045 minus negative 2 times 1.576. That's the numerator, negative 453 divided by 36, and I get negative 12.587. Done. That took me 9 minutes. That's pretty good, considering two things. Well, so yes, I'm the math teacher, and I should be able to do this quickly, but I was also explaining it as I went along, which you won't have to do as long as you're showing your work. But also you're given 15 minutes approximately for an entire FRQ, and so this leaves you lots of extra time to use on a more difficult FRQ. Hopefully this is helpful. If you try to figure out the calculator yourself first, don't come to me with a question like, I don't know how to do it. That's what this video is for. Try and figure it out first yourself. Google it, practice with it, and then bring me a question about the details of what I've done here. Thank you for watching.